Hello there. We're constantly being fed the idea that AI will be replacing everybody. I think this is the wrong narrative. The problem we face today is not the lack of automation, it is the lack of a skilled workforce. We lack the skilled people capable of solving complex problems. And this is exactly why more people need to learn, so that more people can become competitive in this market. This realization led me to the idea of the biggest project yet from my portfolio, a learning platform designed to help teachers reach a much larger audience of learners. And yes, it is using a large language model, but not as a replacement for teachers, because realistically speaking, teachers cannot be replaced no matter how complex or fancy the model is. The model will serve only as a tutor, helping learners understand and practice the materials, while teachers will remain the source of knowledge, context, and educational guidance. Now, like many software projects, this one starts with authentication. From the very beginning, I wanted the platform to support modern identity standards such as OAuth 2.0 and OpenID Connect. And yeah, I could have used Keycloak from the very beginning, but at the early stage, this was kind of an overkill. Keycloak at the end of the day is kind of heavy. And also there was another reason. I'm not that familiar with the OAuth 2.0 and OpenID Connect flows, so the whole system was a black box to me. And this is the primary reason why I decided to do something a bit unreasonable. I built my own OADC-inspired identity service as a lightweight identity provider for development and testing environments, and to understand how modern authentication systems actually work. What I have right now is a system that authenticates the user, issues authorization codes, exchanges those codes for the access and refresh tokens, validates the pkce challenges, and also exposes a protected resource through authenticated endpoints. So even though it is relatively small, even though from a code perspective it is quite straightforward, it still contains all the major actors involved in a real OAuth flow: a client, an identity provider, and a browser moving between them. What surprised me the most was actually the fact that OAuth stops being complex and is quite easy to understand when you stop treating it as a single system that is handling security on itself. When you start treating it as a part of a distributed system, things start clicking in, things start getting in its place. And that makes things a lot simpler. Now let's take a look at how this works. Unlike previous sessions, I am not going to take a look into the code. Instead, I will be looking into the sequence diagram, as the code is extremely simple here. It is quite straightforward. So we'll start with the blocks that we have here, and we have 4 blocks: the user, which is the representation of the web browser in our case, the application, the auth server that handles the authentication and identity, and the database. So in this flow, we will start with an assumption that the user is not authenticated. So here we go. The user is trying to access some kind of protected data, like the profile endpoint, and the application here is checking the browser session, whether it has or not the access token. If it does not have the access token, the application immediately generates the pkce verifier and challenge, and then stores that in the browser session. It is important to note, and this is actually the first thing that was mind-boggling to me, is that nothing is actually stored in the application itself. The whole idea behind OIDC and OAuth is that nothing is stored in the application. Everything is stored only in the browser session or in the auth server. That's it. So after the pkce verifier and challenge are generated, then this data is stored in the browser session, and the user is redirected to the authorize endpoint. So the browser does an API call towards the authorize server with quite a few parameters, like the client ID, meaning the application ID, the redirect URI, and the pkce data. Now, given that the user is not logged in, there is no data in the session that would identify that the user is authorized or not. So if the user is not authorized and the auth server sees that, then the user is redirected to the login page where they are prompted to log in. When the user logs in, the appropriate flag is added to the session, and the user is redirected to the authorize page again, and does the same API call with the same parameters, but this time there is a flag, and the user is flagged as somebody who is logged in. And this time the auth server generates the authorization code and stores that code in the database, as well as the redirect URI and pkce data. That is then being used to validate the auth code, which is a bit later. So next, the user is redirected back to the application via the callback endpoint with the auth code. Next, the user goes to the callback endpoint and passes the auth code there. Given that the pkce data is stored in the session, the application reads the pkce verifier from the browser session, again, as it is not stored in the application itself. Then the application uses the information as well as the auth code to exchange the auth code for the token. So the app is calling the token endpoint, passes the code, and then the auth server does quite a few validations, checks the code, checks whether it is expired or not, if it is used or not, and also checks the redirect URI, does the pkce validations, etc. And if everything passes, then it creates a new token, stores it in the database, and the access and refresh tokens are then being passed back to the application. And it is not stored in the application database as well. It is stored only in the browser session. So the token, both the access and refresh tokens, are stored in the browser session, which then is passed to the user. And now the user is redirected back again to the profile endpoint, and now the profile endpoint is called, but with the access token in the session, and then the application can successfully call the profile endpoint which is a protected endpoint in our auth server, and passes the access token. And if validation is successful of this token, then the data is being pulled from the database. The data is being passed to the application, and then the application successfully renders this data on the website. Now that this is done, let's take a look at how this works. So under the hood, this is a Django project. So we first need to identify the project root, or rather the Django project root. And this is the identity service folder. So we open the terminal and go to the identity service folder. And here we are. Now, there's two options. Either we can execute the Python manage py run server, or in my case, at least on my machine, I found that uv run works faster. So we go with uv run manage py and run server. Here we go. Now that the page is loaded, let me change the scene and remove my face so that you can see everything a bit better. So I will open the inspect from the Chrome DevTools and open the network to show everything that is happening. So here we have the start profile demo button. What we'll do is it will open or rather do the API call to the application, and we'll pass a request with no access token. As you can see, we do not have any access token and any refresh tokens, and nor do we have any pkce verifier. So here's what we do. We start the demo, and you can see we did a call to the profile endpoint, and immediately the application saw that we do not have an token. So the token is requested through the authorize endpoint, and we were automatically redirected back to the login page where we need to introduce our credentials. So we introduce our username and password. Here we have some useful information what will happen next. So next we will call the authorize endpoint, pass the client ID, the redirect URI, the response type, which is code, the scope for which is this token created, well, rather what this token will be created for, the code challenge, as you can see, and the code challenge method. Now we will log in, and we are logged in finally. So what happened is that we received very quickly the authorization code. After receiving the authorization code, the application requested the token, and then we got redirected quickly to the profile endpoint, where that authorization token was then used to get the data from the protected endpoint. Now let's say that we did our stuff, we checked all the things what we need, that we have this username Claude Raccoon, and his learning goals are GLPT and 5, 4, 3, 2, and 1. Quite an ambitious guy. So let's go back home. As you can see, we still have our stored session and refresh token, which means that the next time we will be accessing the profile endpoint, we should not be prompted to log in again. and that's exactly what I will do. So I will press the start profile demo again, and here we go. Immediately we are being redirected back to the profile response, and we can see the same data as before. And to show you that things are working as they should, let me log out again, confirm that I want to log out. Again, we have no access token and no refresh token in our session. And we start the profile demo again. And again, we are prompted to log in. So pretty much this is how the OAuth flow works. So far, this is all that I have for today. And as always, have a wonderful day. See you in the next one.